we're on. This is going to be fun or miserable. I don't know which one.
The latter.
You think it's going to be that bad?
Yeah, because we're usually sitting at Taco Bell.
Very true. We could have moved it to a Taco Bell, but I feel like if we did it there, they'd question whenever I pulled out a microphone and a laptop, and we'd get pestered nonstop, so it'd sound like we were on the radio, like Coach's Corner. Sort of, probably. I don't know. Heck if I know. I'm not a sound technician.
I think there's also the issue of all the background noise of other people.
That would be miserable to deal with. Absolutely miserable to deal with. But yeah. Oh, so what I was telling you about earlier, I found this guy by the name of Eddie Wu. Eddie Wu. He has a website and a YouTube channel. His website's WooTube. He's an Australian math teacher. And he's ridiculous. Like, I understand math, but good Lord. He does some stupid stuff.
I mean, hey, he's got power to him.
Power to him, yeah. He's got like 200,000 subscribers, which is like everybody in Australia. I'm going to Google it real quick and just show it. Because he's the smallest verified channel I've ever seen. Well, like, verified, yeah. I don't see very many small channels that are verified.
Hit or miss.
Yeah. I just thought it was ridiculous that there was an educational person with less than 200,000 subscribers that has it. Now, this is what he looks like. That's what he looks like. He does everything under the sun. Calculus. From calculus to basic addition and counting. I was listening to one of them, and it was the most beautiful identity ever, and it was explaining how you get to calculus. It was ridiculous to listen to. It was like 8 parts. It was stupid. But it took you piece by piece of how you get to calculus. And it was reasoning, how the thought that went behind it. It's like counting. Everyone can count. 1, 2, 3, 4, 5, so on and so forth. Well, it makes sense that after you get to counting, to get to 5, you don't just go 1, 2, 3, 4, 5. You just say, okay, I got 5. You're adding. You're going from 0 to 5, plus 5. 5, 10, 15, 20, yada, yada, yada. Go forth, so forth. Then if you're going to have addition, you're going to have subtraction. Right? I mean, if you're a shopkeep, or if you're a farmer, and you want a cow, going back to Neanderthal times, you're going to trade 400 bales of wheat for 10 cows.
Right.
Because you got the land to do that. Now it'd be like 10 bales of wheat for a half a cow. Because we'd serve it to you dead, no milk. Like, all of its milk from a year stored up inside of, like, mason jars and just hand it over, like, across a black market table. You show up with, like, few dozen white pickup trucks with bales of hay in the back of them. Show up to, like, this undisclosed parking lot, and he just walks out. And one of them's got a big cooler full of steak and stuff of that nature. And then the other one's got, like, souring milk inside of, like, either milk bottles or, like, giant mason jars. Like, the huge, like, foot ones that are, like, bigger than heads that you're able to shove, like, a half a body in. It's like, here's all the cow's milk for a year. Here's half of it. We didn't figure you wanted the organs. So here's your food for the rest of the month. We're going to take food for the rest of the year in wheat. Perfect sense, right?
Definitely.
But yeah, it was like, okay, so I'm going to give you 400 bales of wheat for 10 cows. Well, one of the cows is sick and it dies before you're able to do the transfer. Well, at that point in time, you can't chop it up as well as you did. You did it at your house. So they didn't transport that cow because it couldn't walk itself there. So instead, you got to say, okay, well, I got to cut down on cost. So you start subtracting. You say, okay, I'm going to give you X amount per cow, 40 bales per cow. So I'm going to take away 40. Subtraction. Then you get to the first problem. Because if you go up to a young enough kid, think back to like kindergarten. Let's go back really old. Let's make you feel like an old fucker here for a second. Go back to kindergarten. And if I said 3 minus 5, you'd look me square in the eyes and say, you can't do that.
You're right.
Just because it's like...
They don't teach about 7.
It makes sense beforehand. You can count on your hand. I have 5 and I'm going to take away 3. Okay, well, 1, 2, 3. Now I'm left with 2.
Right.
But I have 3 and I'm taking away 5. Well, 1, 2, 3. Where are the other 2 coming back? Am I going to chop off my fingers and toss them away? Like extra getting rid of them? Or am I going to grow 2 extra fingers? Like the Invisible Man style? Like my thumb just slides over more and then poof, I get 2 more fingers? I mean, it was just that weird, it's that weird concept of negative numbers. But it had to exist somewhere because we were able to count higher. Why couldn't we go lower? Of course, then debt became a thing, and then they really needed negative numbers because now they need to keep track of how much you owe them. I'm going to give you a loan of 15 chickens. You're going to return me all their eggs, or a tenth of their eggs every month for the next 4 years, and that ought to make up for everything. Okay. Then you go on, and you hit multiplication. Well, okay. Multiplication seems to make sense. It's just repeated addition. I mean, 2 times 3, 2 plus 2 plus 2. 3 times 2, 3 plus 3. I mean, it makes sense. It's just repeated addition. So, I mean, that was next logical. Well, okay. Now you got to get to division. Division, you get another one. Because then you run into the problem of fractions. Because for a long time, fractions didn't exist. Those were the Greeks who came up with that. Like, they made sense that they had to be out there, but did they really? Did they really have to exist? Because, I mean, like, how are you supposed to count population? Well, I'm gonna count this child as half of a person. Well, what do you want to do if you want to make it whole? You gonna go split a convict in half and say that half of him's alive? Just, like, take a medieval, or feed him to the lions, but cover like half of him in armor, and the other half isn't, so he gets mauled away, and then they're chewing at his bones. Okay, now we're at a whole person. I mean, it had to make some sense at some point in time. But then you got into decimals, because they began to explore, well, what if multiplication's repeated addition? Then shouldn't subtraction just be repeated subtraction? Or division be repeated subtraction? If I can learn to talk. English is a hard fucking language, isn't it?
Yeah.
But then they start doing it, like 15 divided by 3. Okay, well, 15 minus 5, minus 5, minus 5, 3. Okay, we got an answer. But then you do like 17 divided by 2. Well, how are you supposed to count that? Like, he goes into it 8 times, but you can't take 1 out of 2. It was like, or the really weird ones, like 7, or like 14 divided by 3. Goes into there, what? 4 times? Something like that. 4 2/3? I think that's the answer. And I'm learning calculus, somehow making an A. And I mean, just like the concept of how would you take that away? It was just like, how do you split up these numbers over and over and over? But how do you explore what they do more? Because it makes sense for, like, they based it out of 100 because base 10. And then you had the stupid people like the Chinese who probably based it out of, like, base 2 because they wanted to write in binary for all that we know. Gotta be fancy, don't you? I don't know. I don't know if they actually did that. Why would they care? Why would I care what the Chinese did? But based it out of 100, okay. A fourth makes sense. Okay. 1, 2, make 2 cuts. You got a pie, you cut it in 0.25. Okay. I mean, it makes sense. But then you take like a 7th, a 13th, some number that doesn't make any sense as you take away from it. Like, how do you split 100 into 7 different pieces evenly? You can't. There's no conceivable way. So for a long time, those didn't exist. Once again, until the Greeks. Then the Greeks, they didn't understand decimals, but they understood how they should work. Should work, in air quotes. And they had a few that worked. Well, okay. Then they came up with exponents. Basic principle. Okay. Don't worry about it. But I'm going to turn that off, actually. Who wants to listen to an Apple phone go off? Not sponsored at all, right? But yeah, come up with exponents, because it's like, okay, we're tired of multiplying things by 2. Because you try to represent the growth of, like, Athens and say it doubles in 16 millennia. I don't know. Give me a number, like 3 years. It doubles. Okay, so you've got these mathematicians just sitting back like, times 2, times 2, times 2, times 2, just over and over and over. It becomes this monotonous thing. It's like, there's got to be an easier way to do this. Square it. Let's write small numbers instead of just like this infinitely long row. There's got to be like a building in Rome or Greece that's just like dedicated to records of mathematicians. Because paper was expensive back then, or at least in Greece. Rome, it was a little less expensive because of Alexandria and stuff like that. And Julius banging Cleopatra, that probably made it a lot easier. I mean, they had all the papyrus in the world. Just go steal it from them. I mean, I'm banging their leader. It ought to be free. But yeah, I just want to. I want to know, like, the Parthenon. What piece of it isn't destroyed? Like, or like what they pick up all the rubble and they start reconstructing it. It's like a bunch of eyes that have been engraved into marble. That would be great to see. But yeah, so then they came up with exponents. Well, exponents make sense. But now, if I have... Now I want to go backwards, like I've done with everything else, like multiplication, division. You can go backwards. How do you go backwards from exponents? Well, you can divide by a lot. And I mean, you might get the answer, but you might break every rule of math because they don't understand decimals, remember? So you got to have like 1 through 10 in the denominator. If it's not that, mind blown. Aristotle's going to be lying over on a gravestone because somebody put 1 over 50. I mean, it was just that thought process. So then they came up with a square root. Now we run into a second problem. Second big. You can't do that. So we have negative numbers, and we have nothing else right now. We have real numbers. Real numbers, negative numbers. So then we get to square roots, or just roots in general. Square roots, cube roots, whatever funky number you want to throw in there. And so some of them make sense, like 1, 4, 9, 25, 16. I skipped 1. 81, I'm just going to start skipping around. 256, 196, I think. I don't know. Whatever 14 squared is. I think it's 196. All those numbers, they just sort of, they made sense to do like the square root of it all. But let's go take the square root of 2. Or the square root of 8. Any number. And they couldn't give you an answer for that. So it was around this time whenever the Pythagorean theorem came out. A squared, B squared, C squared, right? Simple. But then you put like 1 and 1 on a 45, 45, 90 triangle, and you wind up with square root of 2 as the length of hypotenuse. What's the number that you can use for that? And so it was this unfathomable concept of irrational numbers that they couldn't explain. Because for 1 through 10, I mean, 1 over 2, it's 0.5. 1 over 3, it's 0.3 repeating. It repeats. There's no end to it. 1 over 6, it's 0.13 repeating. 7, it's like 1429 something. It's like 7 digits that just repeat themselves for forever. And so those make sense. But you get into an irrational number like pi, because pi is only a few hundred years away. 3.1415926538527 something. However many digits there are of this infinitely long digit that has zero sense or rhyme or reason to why it works. So they had to wrap their heads around it. And then the medieval time hit. And everybody just sort of said, fuck math. We're going to go slice everyone's heads off while in metallic armor. And then Japan finally decided to come out and join the real world, and then China kicked them back out. The Mongols came in, conquered everything. Genghis Khan raped everybody, had 5% of the population be related to him or one of his band of like 13 merry men. I mean, it was just like chaos. So math didn't exist. It's a weird thought. Greece. And then the Mongols existed. How much more of a backward step can you take in civilization? It's like we go from having these peaceful places like Athens and Rome and Sparta, whatever the name of that city was, the belligerent idiots who decided that women had more rights than they do right now, apparently. But yeah. So they took a backward step there. And you get into the Renaissance. Right after the Middle Ages. And then it's like humanity got the cold. They got the cold, you get really cranky when you get sick. It's like they get really cranky, they don't want to do anything. And so they got over it. Like hundreds of years later, they got over it. And so they finally got out of it. And then all of a sudden it was like everything clicked, like a good night's sleep. Light bulb went off. Irrational numbers make sense. We don't have to understand everything for once. I think it was just humanity coming to terms with, we're stupid little fuckers. Maybe everything doesn't need to make sense. So now you've got 3 different types of numbers. You've got your rational, your negative, and your real. I mean, that make logical sense. But then we keep on going. So now we understand these irrational numbers. And then you've got people like Newton that come around that revolutionize everything. We're getting around to calculus too. Think about that. Father of calculus. But so then they begin to explore. And then they come to a conclusion. I can't take like negative numbers and associate them with anything. And I forgot to say it, like multiplication, division by negative numbers. It took them forever to figure out, how do you take like 6 and split it into negative 4 parts? It just makes 0 sense. So they eventually got over that hump too. But now they're like, square root of negative 16. I don't know. You can't do that, because it's like, anything that I square, it just like sort of cancels out. Like I took both the negatives and I made it a plus, and now I'm shunning away all the demons that we call the negative numbers. It's like, be gone, Satan! I don't want to deal with you anymore. And then you got some people with balls, like Euler, and probably Galileo and Copernicus, and I've got all of my European history wrong, probably. It's probably going to be someone who listens to this and they're just going to be like, you motherfucker, you got everything wrong. Yes, let me continue. Don't butcher me, little small white child who can't get a life. Of course, as I say that, we're sitting in a dark room all alone.
There's a light on.
Yeah, there's a light on. I can fix that, though. It didn't go down at all.
No, it didn't.
Ow. I missed the light switch. Now it's dark.
Now it is dark.
That's very dark. The demons are coming to get us because we're talking about math outside of school. But yeah, so then they begin to experiment and say, well, what can we do with this? And then all the other mathematicians who are like, it's got to be this way. I've got to be able to understand what goes on. I make sense out of most of what happens. Because you had bankers, you had stuff like that. So the negative numbers made sense. And then pi had already come around. So, I mean, they had to come to accept pi, but irrational numbers made sense after that came out to be, because circles got big for a while, and everybody wanted a ring. So you had to know the diameter, and you had to know, well, how much gold's it going to cost me to go out and rent from this dumbass down the street who's going to cost me a fortune to get it? And stuff like that. So rational numbers made sense, too. And so they complained. It was like, we can't think of this, so they're only in your crazy minds. So they're imaginary. And so, just to slay the naysayers, they called them imaginary numbers. Well, how do you describe imaginary numbers? I mean, for negative numbers, we've got like the number line, right? Number line. Real goes to the right, negative goes to the left. And then you've got the irrational numbers. You use a triangle. 1, square root 2. Easiest one on earth. Diagrams that everyone's able to see so that makes sense. Now, how do you show imaginary numbers? I mean, you just sort of... There's no real way to do it. So what they wound up doing was they took a number line and they're like, okay, we're going to give you a third leg. We're going to take you and drop your balls and turn you into a real man. So they gave it what we would think of as a y-axis, but in math it's a z-axis. On what we now deem the complex plane, because it's complicated and it's got way too many issues for us to figure out. It's like a bad middle school romance. Just off, on. Make up your mind! But yeah. So it was this complex plane, and finally people were beginning to click. And then calculus came into existence. Because we started to plot things along these lines, and whether it be in the Cartesian plane or some French mathematician's name that we put on side of plane for the complex plane. Because everybody has to have something named after them. It started with like an A. It's like Argonasson's plane or something like that. It's something stupid. But then they were like, okay, here's my debt on a scale. As the price of gold goes up and down and up and down. In an economy that's not capitalism, I don't know how that would work. But for some reason, that's probably how they did it. And so Isaac Newton just started looking at it and was like, I know how to find the area of a rectangle. So I'm going to take a rectangle. I'm going to put it underneath there, and I'm going to put as many as I can. And I get accurate to how much space is underneath there, so how much growth I have or how much loss I have, based on how close I am to the gap that's between the curve and the x-axis. Well, eventually you figured out that if you make the rectangles closer and closer together, you have less space that you're missing out. It's like those little right triangles that are right by where the curve should be. Wider it is, the more space you have. So then what if I make it infinitely small? So 1 over infinity, which is one of the first asymptotes you run into, right? Isn't it, pretty much? No?
No. It kind of depends on how you look at it.
It's like 1 over infinity, then it's 1 over negative infinity, infinity over negative infinity, and then... No?
No.
Okay. Then I'm listing off things that are really weird and probably from Calc 2. I don't know how I know these. Actually, I do know how I know these. Never mind. But, yeah. So then he began to ask those questions. And then everything finally made sense after he was like, what if I just begin to draw little lines that I'm somehow able to take the measure of? And then we got calculus, which was which is still one of the stupidest things that we've ever made up. But for the longest time, calculus meant calculate. Like how we get calculator and stuff like that. People used to say, go calculus it. Not go calculate it, because calculators didn't exist. So they gave it to a mathematician who knew calculus. And so it's just been sort of like this weird progression of how math works. But now I have a separate question. Something that my math teacher said. Sinusoids. You know what those are, right? Sine and cosine waves. They're repeating waves that only go x distance apart that are based off of sine. But they're periodic things that happen the same way every time for eternity. They're continuous, domain of all real numbers, yada, yada, yada. So the question that I had is that on the complex plane, would I to the x be a sinusoid? Because I to the first is I squared is -1, I cubed is -I, and I to the fourth is 1. And then I to the fifth is I. Then it goes down to -1, -I. So it's just like, would it actually be it? And I don't know. I mean, yeah, because it would be on the complex plane where, like, complex numbers. So 1 plus yada, 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 all that. It's just like, would it work?
I don't see why not.
I don't know. It was just a question that I saw phrased because he made the comment that these are the only sinusoid functions that exist. So I'm trying to keep this in my mind, and I keep on saying it. That way I can't forget it because I've been out of school for too long.